Today I'm going to be showing you how to create panel A for our sample summary. And so this is a template that I've created, and you can find this under my folder, under protocols, dry lab, sample summary PDFs, and it's this template summary.ai. And so as you can see, there are a lot of placeholders. The reason we use a new template for each donor is just in case we forget to change something from a previous donor, we will not know. So it is best to start fresh for each donor. Now we will first change the name, and so I'm working with D57 FAC09, so that's what I'll type in. Now let's add in our biopsy, and so you can find this under the donor in wet tissue photos, whatever the biopsy site is. And so when you select your photo, try to select the clearest looking image. And so I found that that particular one was the clearest. You can see this is a little blur. So I'm going to select this and drag it in. Now I'm just going to bring it down because it's really big. Okay. So now you want to hold shift just to rotate the image. So now what you want to do is you want to scale it to this bar. So this is our 5 millimeters, and we want to bring this to the size of 5 millimeters. So I'm going to make this smaller. So this is scaled to 5 millimeters now, and so we should not resize this from this point. So what you want to do is select this pen tool, and we're going to outline the biopsy. So I'm just gonna go roughly on the sides. Additionally, if you want to actually see the image, you can just unselect that. Okay, so now that we've outlined our piece of skin, we want to go back to the selection tool. And so if you try to clip this, it will not work because it is clipping from nothing. You'll get this warning. And so you have to select the image, hold shift, and select this path that you just created, and then you can go to object, clipping mask, and make. And so now we have made our skin. If you find that, for instance, I don't like the way this looks, I'm going to go in and drag it out so that, oops, with this tool. So the curvature tool will help you round out the edges a little more so that it looks smoother and cleaner. And so now that we have our skin, this is to 5 millimeters. We don't want to resize this. So now we can move on to our images of our cell clones. And so typically you would have created this sheet of all the sequencing, and so I'm doing this one, and so it's P7G8, it's a 250 cell clone, and I'm gonna look for this image. So you can find that under wet as well, but this time cell clone photos, whatever the site is, whatever the cell type is, and we've started creating these sequence folders to make it easier to find. And so these are my photos. Now I'm gonna hold shift and drag them in. So what I typically do is we have created sizes for the scales that we have in our sample summary. So I'm gonna bring this down to 345. So this has changed both images, the other one's at the back. And so now I want to bring down the 10x image to 256. And just as an FYI, these images typically have a scale bar, but this sample was not saved with the scale bar on it, but you can clearly see which is 4x and which is 10x. Now I do want to mention that these particular sizes will only work for the EVOS microscope, because that was how we have set the scale. However, if you have taken images with the echo, these numbers will not be the same numbers. In the echo, this image, your 4x image, will be 479 in your width, and your 10x image will be 358. Additionally, before you bring down your image in size, you want to make sure that this button is selected and is in its link format to maintain the width and height proportions. If it's unlinked, you will be scaling down the images wrongly. Now you want to crop the image. So here these numbers will remain the same whether you use the EVOS or the Echo microscope. And additionally, you want to make sure this is unlinked because we are not trying to crop to scale. And so for the 4x, it should be 143 in width and 102 in height. And now you want to select the most representative portion of this colony. And so if you see some bipolar morphology and some dendritic morphology, you want to capture all of that in one image. Additionally, try not to put anything in the bottom left corner because the scale bar will fall there and it will be covered. So I will apply this because I'm happy with what I've selected here. And I'm going to align it to this corner, arrange, and send to back. Now we can work on this image, but before I do that, I don't like the coloring on this image because I cannot see the details in the image or the cell's morphology, so I'm going to click Edit Original, and here Preview will pop up. Now you want to select this, and this Adjust Color to change this coloring. And so typically I will adjust the exposure by a bit and the contrast just so that my morphology is clear and the image, it looks better. I don't necessarily adjust the sharpness because the more you adjust this, the more grainy the image becomes. So once you're happy with what you have, you want to save it. Close this. And now when you click back here, it will tell you it wants to update the image. So you can click yes, and now it has given me my saved image. So now you want to crop this. For the 10x, the crop will be 117 and 86. And again, try to choose the most representative portion of this image. So I see some dendritic cells here, some bipolar morphology here. So I'm going to select this section, arrange, and send it back. So now we're not done yet. We want to edit these placeholders. So going back to my sheet, we know that this is a 250 cell colony, and so we want to change that over here. And then we also need the morphology, so I can go back to my sheet and I can see that it's a melanocyte. And so we will put melanocyte here. Sorry. And then we also want to find where this was derived from, so we can go back here and we can see it's derived from the face, so we will put face here. Now the remaining information we can find in the patient info, and so we can go back to our donor and go to patient info, and if you open this file, you can see that the patient was 70 years old and was a female. And so here we can change this to say 70-year-old, and remove the X's and put FE for female. Now select all of this, click this button to align it, and I try to align it to the middle of this image, and that's it. That's panel A. Additionally, we're gonna save 3 versions of this file, so let me show you how that's done. First, we want to save this. I'm going to rename this and put it under D57. So we want to save it in its main folder, call it D57 FAC09 underscore summary. And so we save this here. And the moment you hit save, a pop-up will come out. Usually just leave it as its default as Illustrator. The important thing here is that this is selected. And I'll explain why in a second, but typically you can just leave it as is and click OK. Now, depending on your network connection, this may take a while, but it is essential that you do not do anything or close this file until this saving percentage disappears, or this blue circle. Any changes you make in this time will not be saved. Okay, now that the Illustrator document has saved, we want to click Save As and change this to PDF. Now, the reason we save a PDF is because in case something happened to our Illustrator document, we can actually recover it with this PDF. So important parts here are this Illustrator editing capabilities, the hyperlinks. Just leave it as the default. All this should be left the same. And so we click Save. Now that the PDF is saved, we want to also additionally save a downsampled version of this PDF. And the reason for this is so that it is easy to view, especially on Hunter's end. And so for the name, we just put underscore downsampled and save this. Now, select the drop down and select press quality. You can unselect everything here because we don't need to preserve anything for the downsampled version. To create other sample summaries of the same donor, you can keep the same skin biopsy but replace the images and text. And that's it for panel A.